So folks, now that we've computed a couple of partial derivatives, let's talk a little bit more about the notation. The notation can sometimes seem a little bit confusing. Besides using the notation dz dx to denote the partial derivative, there's many other ways I could do it. So for example, dz dx is the same thing as df dx. This is the same thing as if I said y is equal to f of x. We could give the derivative dy dx is one way we could do it, but we could also write df dx. There's nothing too exciting there with that notation. The other notation that we will sometimes use is a subscript notation. We'll write f with a subscript x, and that's still understood to be a partial derivative. So this means that we're taking the partial derivative of f with respect to x. Those are all correct ways to give that notation. So it would also be incorrect to use the ordinary derivative notation for a partial derivative. So this would be marked wrong because you're not using the partial symbol. The last thing I want to talk about is the nesting of higher ordered partial derivatives, and this can be one of the most confusing things about the notation here. And it's partially because the notation means different things depending on your depending on what form you're using. So first of all, I want to look at this expression here, partial squared f partial x squared. So the first thing I want to do is I want to rewrite it this way. And this is what this notation is short for on one level, where we're taking two partial derivatives with respect to x. So this is a second partial derivative here. The next thing, and usually we don't write this step, the next thing is that what does this actually mean? What it means is to compute the partial derivative of f with respect to x, and then take the partial derivative of that with respect to x again. And there's an ordering here that I want to make sure we're aware of. This partial x refers to this one right here, and this partial x refers to this one right here. So that's how we use this ordered nested notation. I want you to contrast that with the subscript notation, which actually works in the opposite order. First of all, this is saying we're going to be taking a second partial derivative of the original function, and we're going to be taking the partial derivative with respect to y both times. By the way, if I wanted to, I could have written it in this notation, partial f, partial y, which is the same thing as partial squared f, partial y, which is the same thing as partial squared f, partial y squared. But the thing to keep in mind here, so this would be this y, and that would refer to this y right here, and this would be this y, and it would refer to this y right here. So there's a nesting issue that maybe you see that is potentially confusing depending on whether you're using the subscript notation or this sort of form that looks like the limeless notation from Calc 1. So anyway, how do I read this subscript notation? What this really means is we're going to take f's of y. That's how we interpret that. So there's that inner derivative, and we compute f's of y, and then we take the partial derivative of that with respect to y. So again, pay close attention to the ordering issue depending on the choice of notation. So to test you out on that, what I'd like you to do on your own, I want you to take a guess at what each of these are. Don't worry if you're wrong, but I need you to take a guess as to how we would shorten this notation. That is, I want you to write them in either this form or this form, depending on what you were given, and I'll join you in the next page. So take a moment and work through that. So I'm not going to go through that, but we'll pick it up but we'll look at it in the next line. So careful, here I'm saying that the order matters. If I ask you to compute f's of x, y, what this is asking you to compute is compute the partial derivative of the original function with respect to x, and then compute the partial derivative of that with respect to y. Contrast that with this problem here, where when I ask you to take the second partial of f, first you're taking it with respect to y, then you're taking it with respect to x. So this is partial x of partial f partial y. Folks, if this ordering issue is still giving you difficulty, please, it's not the end of the world. You'll get some time to get used to it, but do let me know if you have any questions. Okay, so now that we've dealt with that ordering issue, let's go ahead and take some second partial derivatives here. So here I've got this multivariable function. It's a new one, f of x, y, and it's given this way. And the first thing I'm asking you to do is to compute partial f, partial x. So partial f, partial x, and we're going to do this just as we did before. I'm going to treat, everywhere I see a y, I'm going to treat that as if it were a constant because I'm differentiating with respect to x. So this would be 3x squared, and then this constant of cosine y would just continue along for the ride, so cosine y. Plus, when I take the partial derivative of this expression with respect to x, I'm treating the y to the fifth as if it were a constant. And just from first semester calculus, if I were to ask you to take the constant of ax, the derivative of the constant ax, the derivative would just be a. So likewise here, we get y to the fifth. Now I want you to take the partial derivative, the second partial derivative, and you're going to do it with respect to x again. So I'm asking you to take partial squared f, partial x squared. So that's equal to partial x of partial f, partial x. So I'm going to take my answer from before and take the partial derivative of this with respect to x again. So I'm again going to treat y as if it were a constant and then differentiate with respect to x. This gives me 6x times the cosine of y plus y to the fifth. For this problem here, I'm asking you to take the second partial of f, but in this case, you're taking the partial with respect to x first and then with respect to y. So another way to think about that is we're going to take partial y of partial f, partial x. And so what I'm going to do is I'm going to take the answer from before, this expression, 3x squared cosine y plus y to the fifth, and now I'm going to differentiate this with respect to y. So the derivative of the first expression with respect to y is minus 3x squared sine of y, and the derivative of the second expression with respect to y would be 5y to the fourth. So folks, take a couple minutes, look through that. I would maybe work them again, see if that makes sense, and then I'll meet you in the next problem. So now we're returning back to the original function here. Let me just recopy it. We've got f of x, y is x cubed. And we want to take the partial derivative of this with respect to y right off the bat. So if we were to take partial f, partial y, we're going to treat all the x's in this expression as if they were constants. And so we'd get minus x cubed sine of y. And then we'd have plus 5x y to the fourth, differentiating the second term, treating the x as a constant. So this problem is asking us to compute f's of y, and again, using this notation, what they really mean is to take the partial with respect to y and then differentiate it with respect to y again. So this would be, we'll take our answer from before, minus x cubed sine of y plus 5xy to the fourth, and we're going to differentiate that with respect to y. So that's going to be minus x cubed cosine y, taking the derivative of this, and the derivative of the second term would be plus 20xy cubed. So let's go ahead and take the last one, and I'm not going to do all the work. I'm going to get it set up for you, and then I'll let you finish. So for this one, you finish. So let's get this started. I'm asking you to compute f's of y, x, and remember that that's shorthand for computing f's of y and then taking the partial derivative of that with respect to x. So I'm going to take the answer from before, minus x cubed sine of y plus 5x to the fourth, and I want you to differentiate that result with respect to x. Okay? So you finish this part. So that'll be part of your pre-work grade. By the way, you might get it what you think of as an interesting answer when you compute that, and if you're curious, read the footnote that I've included here. Okay? So folks, what I'm asking you to do after you compute that is I want you to go to page question number 12 here, and I want you to click this hyperlink to one of the pages in our web page, and I want you to try some partial derivative problems. Okay? I'm asking you, in the space below, write out one of the questions you completed and its solution. I feel like if you can successfully complete number 3 and number 4, then you're on track. So go ahead and work those problems, and that finishes up this video. So work those problems by clicking this hyperlink. Give me the question that you were asked for one of these, and then write out its solution, and you'll know you're correct because it will tell you whether or not you've gotten it correct. Thank you, and I'll see you in the next video.